Hello students, in this video we are going to study cycloaddition reactions. Cycloaddition means two pi bonded compounds and to give a cyclic compound. That is why they are cycloaddition reactions. There are two types of cycloadditions we are going to deal with. There are other cycloadditions as well, but at present we are going to deal with only two cycloadditions. One is 4 plus 2, the other one is 2 plus 2 cycloadditions. And look at this 4 plus 2 cycloaddition. How many pi bonds? 3 pi bonds. In the product, 1 pi bond. That means we lost 2 pi bonds. Okay. And look at the sigma bond. One sigma bond is newly formed and here only one more sigma bond. That means total 2 sigma bonds are newly formed. That means 2 sigma bonds are gained. And look at this one, 2 plus 2. How many pi bonds? 2. And here 0. That means we lost 2 pi bonds. Sigma bond, here one sigma bond, here another sigma bond are newly forming. So gain of 2 sigma bonds. Okay. So basically in both the cases you see, similarly we lost 2 pi bonds in both the cases. We gained 2 sigma bonds in both the cases. So this is a typical attribute of cycloaddition reactions. Okay. Now we are going to see how the orbitals involve in the cycloaddition reaction, because we have been right from the first video we have been seeing the involvement of orbitals, HOMO, LUMO, symmetric, asymmetric, plenty of things. How are we going to apply all those things? And according to Woodward-Hoffmann rule, remember Woodward-Hoffmann rule, four plus 2, okay, and 2 plus 2, thermally, photochemically, okay. 4 plus 2 reaction is thermally allowed, photochemically forbidden. 2 plus 2 cycloaddition is thermally forbidden, photochemically allowed. Okay, okay. You need to remember this rule. Okay. 4 plus 2 thermally allowed, 2 plus 2 photochemically allowed. Okay. How is it came to be? Okay. Let's see. First of all, let us deal with 4 plus 2 cycloaddition. Okay. Let us take this one and okay, this one is called diene. Okay, this one is called diene. The other one is called dienophile. Dienophile. Okay, dienophile. Okay, they both add thermally. What will happen? That's what we are going to see at present. Look at the orbitals. If you look at the orbitals, as I said, if it is thermal condition, you need to take HOMO and LUMO. Okay. HOMO is the highest occupied orbital, LUMO is lowest unoccupied orbital. So that from HOMO to LUMO, electron can be transferred to make bonds. Okay. So that is why HOMO and LUMO involved. We take LUMO of dienophile, HOMO of diene. Okay. How can we draw the HOMO? And how can we draw the LUMO? Remember, everyone loves Neha, old heroine Sridevi. I hope you remember that. Okay, 2 pi bonds. That means even number. Even LUMO-symmetric. LUMO-symmetric means HOMO asymmetric. And come here. Here LUMO is asymmetric. LUMO is asymmetric. HOMO asymmetric, LUMO asymmetric. So if that is the case, there is orbital, okay, symmetry matching. So this is suprafacial, okay. Suprafacial is symmetry allowed. Always remember, especially for 4 plus 2, these two cycloadditions, 4 plus 2 and 2 plus 2, supra is allowed. Anterofacial is forbidden. Okay, anterofacial is forbidden. So in this case, we get supra when we perform the reaction thermally. So reaction is allowed. So we get the product. Okay, we get the product. But the same reaction, if we perform photochemically, Photochemically means, you remember, instead of HOMO we need to take what? Excited HOMO. At the very first video, I think we have discussed about HOMO and excited HOMO. Okay, when we go for photochemical condition, electron from HOMO is excited to the next one, and the next one becomes HOMO. So we call it as excited HOMO. Okay, excited HOMO, and this one as usual LUMO. Now, how to draw the excited HOMO? Excited HOMO is nothing but LUMO, as I said. Okay, so excited HOMO is nothing but LUMO, and the LUMO you can draw as it is. You have already drawn. Here you have drawn the LUMO. Same way you draw it. LUMOs and symmetry. But this excited HOMO, I mean LUMO, how can we draw? See, HOMO is asymmetric. LUMO should be symmetric, obviously, because LUMO is excited HOMO. Now see the orbitals. There is symmetry matches, but there is symmetry forbidden. Suprafacial overlap is not possible here. If we want to achieve the overlap, okay, this has to come like that. Okay, so it has to twist. Okay, that means anterofacial. As I told you, anterofacial is not allowed for 4n plus 2 and 2 plus 2. Okay, anterofacial not allowed, so no reaction. That is why I have said 4 plus 2 thermally allowed, photochemically forbidden, because thermally suprafacial, photochemically anterofacial. Okay, anterofacial. And I want to remind you one more formula, the old formula what we studied, Etka, Opka. Remember, Etka, Opka. Even thermal cone rotation, anterofacial. Odd photoconn rotation, anterofacial. Thermal antero means photo suprafacial. Photo antero means thermal suprafacial. Okay. Now look at this 4 plus 2 cycloaddition. Overall, how many pi bonds? 3 pi bonds. Odd number. Odd photochemical anterofacial. Odd thermal suprafacial. In our case, anterofacial is forbidden, suprafacial is allowed. So odd thermal suprafacial is allowed. Okay, suprafacial is possible only at thermal condition, and that is why thermally allowed, photochemically forbidden. Okay, because photochemically it is anterofacial, thermally it is suprafacial. Okay, so without drawing all these things, without these tables, simply Etka, Otka itself we can say whether it is anterofacial or suprafacial. If it is antera, you can say reaction is forbidden. If it is suprafacial, you can say reaction is allowed. Okay, right. Let us see the next one, 2 plus 2 cycloaddition. 2 plus 2 cycloaddition. 2 plus 2 cycloaddition means, okay, let me write it here. 2 plus 2 cycloaddition. 2 plus 2 cycloaddition. Thermally and 2 plus 2 photochemically. By Etka, Opka itself we can say 2 plus 2 means how many? 1, 2, 2 pi bonds. Okay, 2 is an even number. Even, where do we get supra? Even photochemical supra. That means this reaction is allowed only photochemically, because suprafacial, okay, photochemical here. Photochemical we get supra. Photochemical supra. And thermally, even thermal antera. Here antera. That means suprafacial is allowed. So here you get the product. Antera, no product. Suprafacially, you get the product. Hope you understand. Etka Vopka formula. 2 plus 2 cycloaddition. 2, 1, 2, 2 pi bonds. That means even number. Even thermal antera. Even photo supra. In our case, supra is allowed, antera is not allowed. Here supra means photo. Photochemically supra, we get product. Okay. Even thermally antera. Anterofacial is not allowed, so thermally this reaction is not allowed, no product. Okay. That is why I say 4 plus 2 thermally allowed, photochemically forbidden. But 2 plus 2 reaction thermally forbidden, photochemically allowed. Photochemically allowed. For further explanation, just remember, okay, just for clarification, okay, for thermal means you should use what? Homo and lumo, isn't it? Lumo and homo. Homo. How will the homo be? Homo is symmetric always for odd number of pi bonds. Homo symmetric means lumo and symmetric, obviously. Now you see, here symmetry allowed, here symmetry forbidden. That is why thermal reaction, 2 plus 2 thermal reaction not allowed because it is anterofacial. Okay, you have to overlap this way. But if you look at photochemical condition, photochemical means you should consider what? Lumo and excited homo, isn't it? Lumo and excited homo. Lumo, you know, already you have drawn the lumo. Lumo is unsymmetric. And excited homo means what? Excited homo is nothing but lumo. Okay. So here, lumo is unsymmetric means here also lumo unsymmetric. Okay. Now see the orbitals. Symmetry matches. Okay, you get the product. So here suprafacial, here anterofacial. So 2 plus 2 cycloaddition is thermally not allowed because it is anterofacial. 2 plus 2 cycloaddition photochemically allowed because it is suprafacial. Why you get supra, why you get antera? Because you know by writing the orbitals, homo-lumo orbitals. For thermal reaction, you need to take homo and lumo. For photochemical reaction, you need to take lumo and excited homo. Okay. If the symmetry matches, it is suprafacial. If it is not matching, it is anterofacial. Anterofacial is forbidden, suprafacial is allowed for 4 plus 2 and 2 plus 2 cycloadditions. So you need to remember this table. 4 plus 2 thermally allowed, photochemically forbidden. 2 plus 2 thermally forbidden, photochemically allowed. Okay. I hope you understood. We'll see in the next video with a few problems as from cycloaddition reaction in IIT JAM. Okay. Wish you all the best. Thank you very much.